we're going to get started with our crash course now. Can we get a round of applause for Sue and Selena? They're going to be our teachers for today. All right, when you're ready.
Okay, thank you for coming, guys. So, have you guys had a shoot yet? Or edge? You haven't, right? Okay, so have you guys got Spider set up on your computer? Okay, so some of you haven't, so Celine's gonna start us off by showing you how to download Spider. So do this now.
Yeah, so Spider is basically what they call like an IDE, so that's what you use to like edit your code on. And if you just search up Spider, like SPYDER, you search up Spider IDE, and then you just press download for Windows, and just wait for it to download. And I'll also go over parts of like the Spider IDE so you know what you're doing. And then after that downloads, you can open the file. Next, agree, install. Just wait it.
Did you get Spider?
Oh, yeah.
Oh, you're
Oh, so
How do you upgrade it? Because my version is still
just download a new one, and it should be okay. I don't think it'll make that big of a difference because, like, for codes, it's like usually just codes are the same anyways, so it wouldn't matter too much. Okay, yeah. Do you want to start off with the slides then? To start off with Christine's
okay,
slides.
sure. Okay.
Oh.
Okay, so
We just go over like the labs. It'll be really quick.
we'll basically go over every single week. Oh, can you see this? Oh no, you can't.
Oh damn. Oh Henry, do you mind switching?
No,
Oh, never
we have to
mind.
plug this in, I think.
Tech support.
Like, we need to share my screen onto here.
While that downloads.
No, that's okay. Just leave it like that. You can do this. Because it's the share screen of my screen to your screen.
Oh, wow, okay.
Well, we should go over that because that's actually kind of important. Me? Okay. So throughout like the course, you'll hear a lot of people saying, "Oh, sorry." So throughout the course, you'll hear a lot of like your tutors telling you to like get into good style for your code, and it's actually quite important because in your assignment, I'm pretty sure like 15 to 20% of your assignment marks go towards code, go towards your style, and style is actually something that's really easy to fix up on, and it basically just means like making your code readable. So with code, it's actually like kind of complex in coding language, right? So so good coding practice should be like if I write code and I pass it on to Sue, Sue should be able to understand what I wrote. So these are some of the conventions that we have to follow for good code for ENGG1811. So at the top of the document, if we open Spider, this part is what they call like a doc string, and this is where you document everything, all your process and what your code has to like do in there. So you have the name and the author, date, purpose, the data dictionary, which we'll go over later, and you also have the summary and the method, so the purpose of your code, what your code is trying to do. And yeah, so it's a really good habit to get into, and it's really relevant for the assessment. And if you want more in-depth explanation of coding practice, it's actually on the course outline for the ENGG1811 web CMS thing. So you can go online, like, if I can show you. It's bookmarked. And you will have style guide.
Yeah, so basically this is like your Moodle, but for ENGG1811 specifically. They have like a separate website, so you can, everything you need is on there.
And I would really recommend you to follow all these like style guides on there. It's like very easy fixes, like such as like, you know, putting your constants in all capital letters, putting spaces between, you know, equal signs and stuff. It's really easy to fix, and it's also where most of your like easy marks are coming from. And in tutorials, your tutors will penalize you or ask you to fix up on code if it's not up to their standards. So if you have any like questions, just refer back to this page. You'll have access to this during your final exams, but I think in your exams, style is actually not marked. So this is just irrelevant for your assessments and your tutorials. So, where's the
Email.
Okay, yeah.
Okay, so if you guys want to, like, if you have Spider open, try opening a new file. So it should be like here on the top. Oops. Wait.
Why?
That's why I showed this.
Why is that not shown?
Do you want the PC shown?
No, I want my, but I'm switching tabs. But it's not showing.
The screen share's lagging.
Oh, okay. Okay, yeah, I think it is.
Let me try that again. Sorry.
Oh. Oops.
What the hell? Just the uni Wi-Fi. The fuck? Okay.
Oh, okay, there we go.
This way.
Yep, so if you open Spider, on the top here, top left, that little new page button, that should be new file. If you create that, do you automatically get this green text? Yeah, okay, yeah, so yeah, conveniently, like most of it's already done for you, but you might need to add stuff like, you know, what does this code do and stuff like later on. But anyways, so onto actual coding, right? So if you have a computer, obviously, like, you know, like beep bop, like computers can only like think in like one or the other, right? You can't like think and like make assumptions. So you need to be very like direct and like very specific about what you mean. So a computer can read 3 different types of data. So if you tell a computer something, it's either going to be a string, integer, or a float. So basically what that means is a string is like a sentence, like a word or something. For example, like hello, right? Or something. An integer.
In this case, for Spider, you have to put it inside like the quotation marks for it to be declared as a string. So if we go into integer, if you just put 6.5 in, they'll consider it as integer. So anything enclosed in the little quotation marks is considered a string.
Actually, it would be a float.
Oh,
6.5.
oh yeah, string.
Yep. So string is like the computer considers it like a word. Integer is like a whole number, negative or
Practicing
positive.
this spelling.
And a float is like a decimal.
Yes.
Yeah, so like 6.0, like that. So that's how the computer stores it. So notice how here we've got 6.5, but it's considered a string, right? Like, why is it considered a string? Because, like Selena said, it's in quotation marks. So the computer's going to see, okay, it's in quotation marks, so I'm going to like assume it's a word. Okay, that might seem a little bit strange, but like you'll see why that's relevant as we continue on. Okay, so what's this? Okay, these are just things we can do.
This
Okay,
is data manipulation.
we'll continue.
Okay.
Okay, what's
Wait,
this?
maybe you should do that as well. So this goes back to like the style for everything. So we have 2 types with like string, integer, and floats and everything. So I have constants. So constants are basically numbers or like letters that won't change throughout the code. So good style practice would be naming that as capital letters. So revolution, gravity. So for example, if we want to like declare, how do I switch? If we want to declare like gravity as a constant, we would put that in all capital letters, 9.8. And like right now, I'm not getting the code to do anything, right? But this is the run button right there. If I press run, it should do, and it will come up at the variable explorer as gravity. And here's the type of the data that we were talking about. So it's a float because it's a decimal. For the size, you don't really have to worry about that at the moment. It's not really relevant to the course, but you have the value right there. And it's really helpful, like later in the course, if you have multiple constants or variables, you'll be able to debug everything just by looking at this. And it's just a good way to like track what you're actually doing with your code. Oh my gosh, it's not, I'll go back to it. So variables is like lowercase, so these are numbers that will be probably changing throughout like your code. So it's really important that they're meaningful, so don't like label your number as like well, like if it's a random number, name it as a number, because if I show it to the next person, they're not going to know what the number means. So more like appropriate naming might be like temperature or mass, and yeah, stuff like that. So math libraries. So with the code right now, there's actually multiple libraries of code that you can import into Spider. So one of the examples is like the math library. So if we search up with math library, Spider, we can look on this. So this is Python docs. If you do mathematical functions, we can like implement all these like functions to help our code a bit. So for example, if we want to like find the factorial, we don't really have to come up with the code to calculate what a factorial is when we already have that in the math library. So to do that, you can just go on, oh my god, right here at the top, and you can import what is the library? How do I import the library? So, oh, they don't even have that right on there. So import, and you can import math. So for here, if we import math, we can access like the pi number, which is like right here. We have it here as a math constant. So, and we can only use that after we import the math library. So make sure you import it at the very top of your code, because code actually runs in sequence, like in order. So whatever code that you put at the top, it will run first. So if you put like, if you say math.py, but then you import the math like later on in the code, the computer's not going to know what math.py is because you haven't imported the library yet.
Yep. So.
Oh my gosh.
Yep. So basically, if you want to use these like formulas, then you just need to write import math at the top of your document.
Should we show that? Show them an example just to import.
Yep. Do it on mine.
Yeah, I'll open the slide up there too. So for example, if you want to import math like that, and then we want to set the radius, but the radius is like, for us, it can be any number. So we'll name that as like a variable. We do 5. And if we were to calculate the circumference, it's 2, and then pi, but we have to access pi through the library, right? So we have to do math.pi times the radius. Oh, does it? Oh yeah, like right now. And if we want to print it out, we can just do print. And we want to run the code, and it'll print out the circumference, right? So yeah, that's what it is right now. So if we, like what I said before, if we do import math like after everything, it'll throw an error and it'll say math is not defined. So that's actually a really important thing to do throughout the course, is actually to learn how to debug properly. So reading the error messages and just knowing what like mistakes you have, because when you have so many lines of code, it's really hard to know like what actually goes wrong, because it'll just spit out like a bunch of like you know, messages. But if you don't understand what they mean, it's really hard to debug your code. So that's something that comes with practice. So if you say like name math is not defined, now you know that it's supposed to go at the top. Yeah. How do I switch?
Yeah.
Does anyone have any questions while they're getting on the next slide?
Does it matter if you put it in that one or little box?
Yep.
It's
So
yeah.
do you want to explain the like?
Oh, like the actual, okay. So every single code that you write would go to this side. So that's actual what they call the text editor. So that's where all your code should be going. And this is called the console. So the console part of the IDE is actually how you interact with the code. So we wouldn't really be coding in this part, because that's how we just kind of talk to the IDE right there. So for example, if I want to do, one way we interact with the code is, if we want to do like, just temperature, for example. I'll just do temp, and we can just do input, like enter the temperature, and we want to print the, oh my gosh, is like that. If we run that, it will say, that's the code I told it to do, right? So I've told the code to say enter the temperature. And if I do like 5, for example, it'll say the temp is 5. So that's actually how we interact with the code. So for here, that's where we feed the number, we feed the instructions, but this is where it actually processes everything. So when you're writing the code, usually it's on the left-hand side.
Yeah, think of it as like a chat. Like if you're on like Messenger, you're like, wait, go back to the thing. Like if you're on Messenger, like this side is like what you're messaging someone, and then you press send, which is run, and then it goes to here, and then the computer like reads the message and does whatever, and then gives you an answer and says this is the answer. And then up here, this is like Selena said, this is just like a summary of like all the things you've told the computer. So like the variables we made is like circumference, gravity, radius, and temperature, and then what they are. So if you ever need to check up on the numbers, you can like check here. Just make sure you have the right numbers. But it will like become more relevant as you like do harder questions, that top part.
It's not really recommended, but you can do like 1 line of code. So that's what they call input. So what you put into the computer, for example, like today I did 1 + 1 and it just spat out like 2. So that's how you actually communicate with the computer. But write all your code on this side to make it easier. Okay. Yeah. Oh, I kind of went over this before, but this is like the print function. So that's kind of what I did there. But what they're saying is the computer can't see. It's actually kind of stupid, but we have to be very specific with the instructions that we're giving them. So if we want to do like print the circumference of a circle is, we have to like put like a plus sign on there. So it's just like combining like the letters and numbers and putting it together. So if we want to print that out, it's like the circumference of a circle is, and then circumference, right? But then circumference is a number and you can't add like different data types together. So this function actually turns the float into a string. So that's how you print out the whole sentence out.
Yep, so let's go back to the code. Yep, so in this situation, what is
temperature?
yeah, what kind of data type is temperature?
I mean, the hint is already there, but can anyone tell us what the data type of temperature is? What's it?
A string, right? Because, so for example, if it says enter the temperature and we type in 10, right? And then press enter, why doesn't the computer think it's the number 10, but instead it thinks it's the word 10?
Because it's in like the little quotation marks, right? Like right there. But if we want to change it, for example, if we want to set it to 8.5, that's a float now, right? Because that's not in a quotation mark. But if you run the code, it's going to say, oh, it's an error because you can't add different data types together. Like the computer doesn't understand what it's doing because that's a string right now and that's a float. Does that make sense?
Yeah, so as you can see here, like this type now 8.5 is a float, but this part, the green part, is a string, right? So we can't print string plus float. We need to change this to like string plus string to make it make the computer let them add them together.
Okay, so can anyone like come up with like a quick fix of how we can like make it print the temperature is 8.5? Yeah, so you can add like the string. So how do we make it a string again? Oh yeah, we can do that. Like that. Okay, that works. Is there any other way? There should be another way as well, but that's a really good one. Good job. Yeah, quotation marks, yeah, that's right. So we do that. And that also works, right? Yay! Yeah?
What was the difference between single quotation marks and double?
Oh, that's something that was actually asked.
What is? I don't even know the difference. I thought there's like no difference.
I think in Python there's no difference.
In Python, there's no difference, but
yeah.
I'm pretty sure there is a difference in like other coding languages. So for now, it should be fine. But most of the time, like this would still work. I'll do this. That will still work, but I would recommend to do single. Yep, do single. Okay. So that's basically 1 week of content done.
So is there a difference?
Yeah.
About that? If you go back to the slide.
Oh yeah.
Yeah, the top one, then the circumference, and you put a code. Yeah, the comma and then you put.
That would do the same. Well, we'll have a look.
It's all the same, just.
Yeah, so in code, there's actually multiple ways of doing things. That's why I asked, do you know like one way to like fix this? There's like multiple ways, but for me personally, I just like the plussing because it just makes sense. Like you're adding and pressing everything together. But if you want, you can do it that way as well. So if you convert it back to like, but that would also work because for here, you don't have to convert it back to like a string as such, because you're not actually plussing things together. You put a comma after it, so just print out whatever it is. So it's just whatever that you feel comfortable with and whatever you can remember in the exam. So yeah.
Okay,
Okay, that's week 2 done. Yay. Do you want to go through it now? So it's pretty easy.
Okay, so another, like, you know how I was saying, like, computers are like people, like a type of things you can tell a computer is whether it's true or false. So, for example, like, if you say 3 is greater than 3, like, obviously that's false, right? So, you would tell the computer, like, 0. Okay, so another example, like, is 3 greater than or equal to 3? That's true, right? So, like, when you write that and then send it to the computer, it will tell the computer 1. Like, it's not going to say true or false, it's going to say 1 or 0. Yeah, so that's what Boolean means. Boolean basically just means 1 or 0. Yep. Oh. You love this. Okay, so now we're getting to real coding. So now, like Selena showed you, we can like put in a number and then tell the computer to print out something. But now, what we want to do is actually tell the computer to do something for us. So there's something called if statements. So basically, you ask the computer, if something is true, then do this. And then else, if that's not true, then do something else. So we're giving it like a set of instructions, right? And you can think of it as like a tree. So if something is true, like you have like the arrow and it's like yes or no, and you just like follow it down. That's basically what it is, but we have to write it in word form, okay? So how we do that is we start the line with if, and then like something, then do something. So the do could be like print our sentence or something like that, right? So let's keep going to see an example. Okay, so this question is saying the first line is like it says please enter your mark, and then it's going to wait for you to put in your mark. Say my mark was 99, right? So I put 99 and press enter. Then the computer will see is the mark less than 0 or greater than 100. No, right? Because 99 is not less than 0 and it's not greater than 100. So it's not like out of the range. So it's not error. So since it's not this first line, it's going to skip to the next line. So elif mark is greater than equal to 0 and mark is less than 50. So my mark is not between 0 and 50. So it's going to skip this. Then is my mark greater than 50 and less than 100? Yes, right. 99 is between 50 and 100. So therefore, it's going to print my grade is pass. Right? So yeah, so basically it's going through each one, seeing which one my number is part of, and then it's going to say what it is. Okay, so what is elif, right? So elif is basically, like the first line says if, right? And then if the first if is not true, then it's going to go to elif. Elif is short for else if. So else, if this is wrong, then if this is true, do this. Else, if mark is less greater than equal. So it's kind of like putting if, but it's slightly different. Because it only goes to this if this is not true. So hopefully that becomes more clear with examples.
Yeah, and it's also important to highlight that we mentioned it before, that there's multiple ways of achieving the same thing with code. So all 4 of these codes actually do the same thing, but it's just like slight variations in that. Because if you see this, like first they all filter out if it's like less than 0 or greater than 100 to print error, right? But then you have elif, which is basically, that's kind of the same thing. And then you also have else. So you use else as the very last resort. Like if and then else doesn't go through, else is like what it would do if none of the conditions above like satisfied. So, but they all mean the same thing.
Should we do like an example maybe?
Oh yeah.
Okay, maybe everyone can code this together.
Do you want to come up with an example? Oh my god, how do I switch? There it is. What examples would you like to do?
Is it like maybe like
Is it too hot?
yeah, so like what's the temperature? And then like if it's too hot, then say like it's a nice day. If it's too cold, say like wear a jacket or something.
Yeah. Should I just get them to kind of do the exercise first? And then talk us through it? Or should I just code it up as well?
What the first thing we should try is? Yep, exactly. So we need to like ask like what's the temperature, right? So we need to know what the temperature is.
Like that? Okay.
So now like when we run this, the computer can like you can write what the temperature is, right?
So you have 10, so that works. Okay.
So let's say like if the temperature is less than 20, then it's cold, and if it's greater than 20, it's hot. So yeah, what should the next line be?
So if it is cold, and so what would the next thingy be? Yeah.
Yep. Okay, what's another way we can write the second part? If like without writing numbers.
Yeah.
Elif one. Yep, exactly, right? So else would be the same thing as if the temperature is right. So let's see it happening here.
Okay. But before that, that's an error. So for example here, we can see an error here. It says we can't compare two different data types, right? So we can't compare a string, which is like letters and like text, with integers. So what's something that we can do to convert it? Yeah. So we can use this function. That's kind of what we said. Convert it back to like an integer. Like that. We run that again. Yeah, then it works, right?
This 20 degrees is hot, and then
If we do like 1 degree, it is cold. Yeah.
any questions so far?
You just do a space between the lines and code that's kind of separate, and then the way you do, if you print like slightly to the right, why is that? Is it related?
Yeah, basically. So this is called an indent. So you know how like if this happens, then do this, right? So this like happens because of this. So then we put it kind of like inside. Imagine it's like inside this if box, right? And then if this if runs, then it does the stuff inside the box. But if this is not true, it will skip straight to the next line that has like on that line.
You can have multiple indents.
Yeah, so multiple indents will happen if you have like if, and then if inside. But like, yeah.
It's not really in this course, but if you do like a more complex code, they'll actually like mark you on like the amount of indents you have, just because it looks really messy. But in this course, I don't think they'll ever ask you for like too many, because it is an engineering like programming course. The point of this course is actually not to like program, like make apps and like make games and stuff. It's more to do like mathematical calculations. So for this course, just think of it as like a calculations course where you're just entering numbers in. So you don't really do much like game design and stuff like that. So you wouldn't really need to use like 4 indents. And plus with the indents, they actually come up automatically. So if I do this again, like if temp equals 20, finish off with this, and I press enter, it automatically gives me an indent. So
Good question. Why is it giving an error for the 1 equals sign?
Where? Oh, on the side.
Yeah.
oh, okay. it's giving an error, right now, because I'm telling it to, like, if that condition is satisfied, to do something, but I haven't actually told the computer what to do, right, because I just deleted the code. Oh,
It's double equals.
that's right. But now there's still an error because there's nothing inside. Okay, so there was 2 errors in the one line because now if we wanted to make it equal to something, if we look here, we're assigning we want to assign something to a variable or constant, we use one equal sign. But if we want to make it make comparison, we use double equals.
So basically, if you're doing like if something equals something, then you need to put 2 equal signs. So that's just like a formatting.
I'll fix it.
Thing to keep going.
Okay, so if we want to do, for example, 1, it's not good if we do 20 degrees because we say if the temperature is equal to 20, then the temperature is perfect, like that.
Okay.
Kind of done that already. Okay, this is kind of what we went over, but
Yeah, so when you're doing like if with cases, think of it as like a number line. You know, like you're thinking of the different ranges, right? You remember like in like HSC maths when you did like you know those questions that are like x like, you know, like there's like inequality questions, like where you have to like draw a little number line and make sure you like, check each range. Yeah, think of it like that. You just have to like check each case.
yeah, just make sure, I don't know, when I think of like if and like else statements, I kind of think of it as like a filter. You're putting in a lot of conditions and like step by step, the conditions get eliminated. So when you're like thinking of like grades like this, you have to make sure every single case is considered. So like you wouldn't really expect someone to put like a score over 120 if it's out of 100. So you need to make sure you eliminate that. Otherwise, like the computer doesn't know what to do. But this like kind of comes in practice, just kind of get a broad like range of cases that can happen and just eliminate them as you go. So that's a kind of a visual way to do it.
Okay, week 3.
Week
Week 4.
Week 4. That's when you get your assignment, but we don't really worry about that now. Functions.
Okay. Okay, so functions, right? So now we know how to do like if and like print. Okay, but like how can we like there must be more to like coding, right? So functions is like a big part. It's like where you really step up like the complexity of like what you're doing, right? So a function is basically like it's like a little packet of code that you can reuse. Yeah, reuse, right? So for example, like you know how Selena was showing you about like the like factorial function? So like for example, if you write like import math, then you can use like the function of factorial. Okay, maybe Selena can type it for like okay, never mind. Okay, factorial something, right? And then you can just automatically calculate the factorial. But then basically what this is a function. So what factorial is there's a separate code like somewhere else that says like define like factorial and then some inputs and then it tells the computer what to do. So like, you know, print like n what's factorial? N times n minus 1 times n minus 2, like that, right? So then when we call the factorial function, like this is already coded for us, but somewhere else. So it can help us to like condense our code because we code like a little section somewhere else and then we bring it back to our main code. So
What's wrong with this? I'm trying to figure out what's wrong with this.
Selena, there's no up arrow in Python, there's double.
Oh my god. C. There's still something wrong with this. Okay, like that. So another reason why we would be using like functions is, for example, if we want to calculate like the square of the number of multiple numbers multiple times, it's really annoying to just go like, oh, I want to find the square like of a number 5, but I want to change, I want to find 6 now. And then you have to like change this, you have to keep changing it over and over again, when we could make it simple and make like a function that would do everything for us. That makes sense. So to like kind of declare a function, we would put def. So that's like making a point that we are calling this a function, and we can say like square function, and we can make it input.
Yep. So keep going, keep going.
Okay, yeah. How about you explain it while I keep typing
Yep.
it?
So def is basically telling the computer, okay, well that's to start writing a new function, right? So you know how like when we wrote if, it's like telling the computer, okay, we're about to like compare two things. We're telling the computer, okay, we're about to start writing a function. Then she wrote square underscore function, right? And that's actually just like any random name that Selena came up with. Like she could have written like you know, she could have written like Stevie toilet. But like it's just like the name, right? We've given the name. And then in the bracket, she's written what we're going to input into the function. So this is like the number that we're going to put. Like we're going to give the function, and then the function will like take our number. So think about like a production line like machine, like a factory machine. You know, you put in like corn, and then like the factory does this thing and it comes out with canned corn, right? So we're putting in the corn, which is number to square, right? Then and then inside the function, something's gonna happen. So we're gonna write some code to like change number to square, right? Which we'll see what something's gonna do.
Oh god, did that even square?
Okay, so we're putting in
The frick?
because you didn't square the
There it is. It was really laggy, that's why.
Okay, yep. So now what we've done here, we put in a number, and then in the final line, it says print the square of my number is, and then we called the function. So we called the square function, and then we're gonna do the square function to my number. So what is my number? My number is from here, which is 5. So we put the number 5 into square function. So 5 goes here, return 5 squared. So then, now, this big thing will equal to 25. So then you'll see the square of my number is 25.
And what's really easy about functions is if you change like one little thing in the function, that would apply every single time to use it. So if I want to cube like a function now, I can just simply change this, like just ignore the naming conventions. If I change this to power 3 and I run it again and put in number 5, it will like put in the cube of that number. So it's like really quick and efficient. If you didn't do it in a function, you will be like changing a lot of numbers. So yeah. Any questions so far?
Why does it say return? Good question.
That's just kind of the way the code is. Like you're just telling the computer what to give back after you put in the number. So for all the functions, you would be returning something. Otherwise, it will be kind of like pointless to have a function, I guess.
Think of your whole code as like the factory machine, like I was saying. So in the factory machine, like in this specific function, we put in the corn, and then this is going to be our canned corn that comes out. Okay, so return just means like what the machine is giving back to us.
But I guess there are instances where you don't use like return. If you want, you can just make it print out the thing instead of returning. But that would be different because like now when you call the function, it'll print it out for you already. So if we just do square function and give it like 5 and run it. Wait, which one?
Yeah, line 11.
Oh yeah, line 11. Oh, that's right. If we do that again, then we didn't need to write like print this out again, right? Because we're already telling the function to print out the number right away. So multiple ways.
Question: Is the function usually written like in this part of the code, or like at the top? Or?
Doesn't really matter
Okay, so
as such, but it is recommended for 1511 that the function is declared above everything else because it runs in chronological order. So I would say to put it above everything because again it runs in order. So if you don't declare the function before you call it, then they don't know what the function is. So if I put like this above that, it's gonna, oh, did it not come with an error? Oh, here, it will come up with an error because I didn't even tell the computer what square function is because I put it after I used it. So put your functions at the top before you use it.
So how I like to think of it when I'm like checking my code is like I pretend I'm the computer and like I go from line 1 and read down. So my number equals input into a number. So now my number equals 5 or whatever equals the number. Then and then it's a square function of 5, right? But I don't know yet what square function is, so I know it's going to be wrong. But if we move the square function back to like above that somewhere,
It can literally go at the top and it'll still work, remember?
yeah, it can go to the top because I can read from line 8 and be like, define square function for what? Okay, it hasn't done anything, right? It's just like defining what the function is. And then it will say this, and then when I get to this, when I see square function, like when I'm checking, I'm gonna go to what is square function and then start reading from there again. So it's gonna say number to square, that's the number in here, which is 5. Then print 5 cubed. So then I know that from this line it's gonna print 5 cubed.
Yeah,
Yeah.
let's change it to cube. Yeah, that'll be like that. Okay.
Okay.
We've already kind of went through all of that. I mean, with functions as well, you can do like multiple inputs. You can put in like 2 numbers or 3 numbers. There's kind of like no limit to it. Like right now, to make things simple, we've only like made the function cube like a number. But if you want, you can make it like times a number. So you can put in 2 numbers. Do you want to do a demo of that, or do we kind of understand what's going on already?
Should we do another example or keep going? Maybe we can do another example like when we get further.
Okay,
like other functions.
sure. Functions. Yeah. So that's the output.
You can also have multiple outputs.
Yes.
I think a few of these slides will show that.
Okay, let's do an example, I reckon, of multiple inputs and multiple outputs. For example, maybe like you're programming what your computer.
A programming slave.
Say like, okay, what's like a case we have to like add 2 numbers? Maybe like how many students in Savannah course, right? So maybe number 1 is how many first years, and then number 2 is how many second years.
Wait, what's the example again? I'm so sorry.
How many students total?
Oh, okay.
So say like number 1 equals like.
First years.
Yeah, sure, okay. Another like thing to note is it's a good idea to always name your like variables something like relevant. So you know how she changed it from number 1 and number 2, like first years and second years. Like she has like more descriptive, right? So when you read or when you send your code to someone else, they can know like, okay, this is like a number for the number of first years instead of just like what is number 1, what is number 2, right? Okay, and then so now Celine's writing a function to find the total students. So what is she doing? So this time in the corn machine, she's putting in corn and sugar syrup. Okay, so there's 2 things going inside, and then what's coming out is the corn and sugar syrup together. Okay, so she added them, and then that's the output. So that means when she calls the function, the total students, and she puts in 120, 100 and 200, you should come up with 300.
There you go.
Yeah, okay.
Ta-da!
What about with multiple outputs? So let's say like, for example,
Okay, we do that.
or maybe if we have, okay, yeah.
I mean, it's probably not relevant if you go over lists for multiple outputs, because then it'll return a list of outputs. Like, this is not really too relevant at the moment. It'll be too hard if we do multiple outputs right now.
Did they cover this earlier in the course?
This is list now.
This is list now, so that's why I'm like, maybe we should wait until list.
Okay,
So yeah, this list is another data type on top of strings, integers, floats, and booleans that we've learned. And it's basically a collection of ordered data. So list can contain strings, integers, floats, and booleans. So right now we have a list, and basically this is a list of strings. So we have in as the word, square, bracket, separated by commas. And also we can have a list of like just an empty list. So that's how we declare it. So if we make a list, you have to make sure we use square brackets like that. And there's actually like easy ways of like making or populating a list with just like simple arithmetic operations. So for example, if we want to make a list of 3 6s, we can just do just a single list of 6 multiplied by 3, and it creates like a list of 666. Or you can like add things to the list by just using like an addition sign. So if you want to add like a list of 6, just a random like 6, 7, 8, you can just add that all together and it'll combine it together into one list. Like that. And also what's really important is like in computing terms, they actually start counting from like 0. Whereas like intuitively we start counting from 1, right? So if we want to say like what is the word at like the 0th index, it's actually the word in, because we count 0, 1, 2, 3, 4, 5, like that.
So it's like saying for the list. So the reason why, like, the thing we need to most do like regarding list is like refer to which one in the list we're talking about, right? So for example, if I want the word brackets, then I have to tell the computer, okay, I want the 0, 1 second index of a underscore list. Okay, so like that's how we like refer to the number inside the list.
But it's important to know that if you're finding the length of a list, you actually have to count it from like 1. So it's like 1, 2, 3, 4, 5, 6. That's the length. But to access the thing at the very end, you start counting from 0. Yeah, it's kind of confusing like that, but it's just the way it is, and it's not something that we can change because that's how everyone uses that. Yes. So like right now, for example, if we declared a list to be like in square brackets separated by commas, and we want to find like, if we want to like slice it or like take a specific element out of the list, we can just use like a list and the square bracket 1. So that's 1, right? So we have to count 0, 1. So if we do this, it will actually print out like square. So that's how you access like elements in the list. We can do an example. My list. Square bracket.
Yeah, just while she's doing that, how would you say that ChatGPT helps with this course?
Oh, wonderful! I love ChatGPT. Yeah, make sure you get ChatGPT. So, just yeah, like.
What kind of stuff do you normally ask it?
Like I like copy paste the question in and say, can you solve this for me? Or like something. But ChatGPT is obviously not always correct. Like it's rarely ever like you can copy and then like paste it in. You have to like paste it and then be like, okay, what did it do wrong? And like always like does something stupid. But it's like it's good to have it there so you can like look at what they did and then be like, okay, so that's what I have to do in like is as like the code. I just need to like fix the variables or something. So yeah, ChatGPT is very helpful.
Good starting point.
Yeah, it's a good starting point.
Make sure you don't copy code straight from ChatGPT though. Like if in really bad scenario where you actually have to use the code from ChatGPT, at least make an effort to like change the variable names or like change like the loops and stuff. Otherwise, it's like really obvious that you copied straight from ChatGPT, and plus ChatGPT is like fed from like all the data that everyone else is putting in, right? If like multiple people are asking the same questions to ChatGPT, then it's gonna feed the same things like back to everyone. So that's like when you kind of get flagged for like plagiarism. So yeah, just make sure you change stuff if you actually do need to use it. But like just in the final exams, there's no ChatGPT, so try to like, I guess like use it without. Otherwise it's very hard in the final exams if you're relying on ChatGPT. But yeah.
Actually, how I first use ChatGPT is I usually do the question, like I try my best, and then like it comes up with like errors, right? And like if I don't know how to fix it, I'll copy paste my code into ChatGPT, copy paste the question into ChatGPT, and say what did I do wrong, and then it normally tells you what the error is and which line. And I'm like, okay, good, now I can fix this error, and it should like continue your code.
Yeah.
Yeah.
So ChatGPT basically just like helps you read this part sometimes. But if you can learn how to read this, then you're all good. Then you'll do fine in the exam. But like, yeah, this is my list, and we said hello, hi, how are you? And again, that comes up over there, right? So how would we access like the word how? My list? Like that? Okay. And oh, we want to print it out. That'll be my list. Sorry.
Another way to like check, like do a lot of error checking is to like print stuff, because like you don't know what's going on here unless you tell the computer to print something. So yeah. So you don't know if it was correct until like they print it out to see if it's not the right.
Yeah, like that.
Oh, okay, so printed how, so that's correct.
I'll make that more informative. So here we have the list, and we want to call the second, the second index of the list to be word. So we have my list, we're telling it what list to look for, and then what index it is. So it'll go back to my list, and then 0, 1, 2, and it'll store how to word, and then we print the word out, and it prints how. Yeah. Any questions so far? No? Okay. Yeah, so we were talking about like manipulating lists with like pluses and multiple signs and stuff, but this is also a shortcut to create lists, and it generates it by itself by taking 3 like variables, so start, stop, and step. So like for example now, if we want to like make a list of numbers that goes up by 2, we can say we want it to start at 0, but we want it to stop at 16. But it goes up by increments of 2. But it's important to know that it stops at 16. So if you want to make a list that includes 16, what would you change that to be? Yeah, we can try that. Okay. Let me just delete everything. So we have the range. Before we had 0, 16, 2. And I'll store that to like list 1. And if we run that, that actually doesn't print out anything, but we can print that out. Print out list 1. Oh my god, why isn't it? Why isn't it? Why is it not working? Huh? Okay.
Just put that inside the frame.
Yeah, I'm gonna try to do that. Oh my god. Let me think how to do it.
Okay, technical difficulties. But okay, I'll continue. So, yep, so you can have the start, stop, step kind of format with the 3 numbers, or you can just, if you just put in the one number, it's going to assume starting at 0 and then like going up by 1, right? So yeah.
Wait, I swear to God, that's what I did. It is a square bracket. I thought I did that before. Hello? Okay, maybe it's time to use ChatGPT.
Just try like range and then a single number.
we don't need math.
Instead of multiple like inputs into the range function.
Oh, just one? Okay, let's try just 10.
Do I think that works?
No.
No, it doesn't work.
Okay, well, it's supposed to work. Imagine it works, right?
Wait. I actually do want to know why it's not working.
Okay, but something about range is you can only have integers. Remember, integers is whole numbers. So you can't put it like, oh, increase by 0.4 at a time. Because 0.4 is a float.
Oh.
For loops.
Oh, 4 loops!
There you go. Oh my god. Okay.
Surely it's supposed to work without doing that though, right?
No, because you can use range and for loops as well, so you have to like specify that it's actually a list. But yeah, if you want to use like list to make if you want to make a list using range, you have to specify that it is a list. So yeah, put the list in front of range, and like right now, it creates up to like 14, right? But if we put like 17, as I said, it goes up to 16. So yeah, Monica was right. Yay! Good job. Yeah, that's clarified. For loops, Stu's favorite.
Okay.
We'll turn on the webcam just for this.
So
Stu's gonna do the examples too.
let's say like, for example, do you guys do like for you maths? No? Okay. For example, imagine if like you're doing guess and check, right? So you know back in the day, like you need to like guess like if like a number is right or something, and you have to check. Let's say you're checking from like 1 to like 10, right? So you have to like, for example, it's like x plus something, x plus 5 equals 6, and you have to like figure out what is x. So you're gonna sub in like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until you find the right answer. So obviously, like for a computer, it's gonna be like to our advantage to make the computer do repetitive tasks like this, like guess and check, so it can like find the answer for us. So how we can do that is by using for loops. So for something in something, then it's gonna do something. It's gonna keep doing something while this is true, right? So let's look at an example. So it says for I in 1, 2.5, ABC, it's gonna print that. And then, yeah, so, okay, so what is this 1, 2.5, ABC? So have a note that it's inside square brackets, right? So this is a list, right? So what I means is it's going to go from I equals 0, 1, 2, 3, 4, 5, 6, 7, 8, and keep going up. But like during the time that it's inside the list. So if I equals 0, which, like what do you think it's referring to for this? Yeah, remember, because the index goes from 0, 1, 2, 3, 4. So if I equals 0, then we're talking about the first one, which is 1. So then it's going to print 1. Okay? And then note how we've got an indent here, and then this is like outside of the 4, right? So we have to keep doing this until it's done. So from here, I'm going to go back up to the top. Now I equals 2, so we're looking at 2.5, right? So I equals 2.5, so it's going to print 2.5. Then back to the top, I equals ABC, it's going to print ABC. But then, now it's like all the i's are finished, right? So it's going to go to the next line, and it's going to say print done. Okay, so should we see how that looks like in Spider? Oh, okay, sure. Okay, do you want to come up with an example or something? Let's say like, maybe we
So
can
we're-
write everyone's name.
Yeah, so like an example that we did in past before was like, for example, if we have a really, really, really long list of names and we want to search if a specific name is in the list, that's what we can utilize like for loops are to our advantage. So if we do list of names,
You can say like,
Tom, okay, Selena, Sue, Henry, I don't know, Helen. Just imagine the names goes on and on and on. And if you were to manually like look through the whole list of names, it will take a very long time, right? So we can use for loops to our advantage. So for let me look at the index again.
for I
In and we can do a list of names.
Yeah, so instead of actually putting the list of names, you just write list of names and it can refer back to the top.
If I equals 2, because we're actually like making it equal to something. Who do we want to find? Let's find Sue.
Oh, okay. So
If the name equals 9, then we can print person found. And then okay.
maybe
Yeah.
wait.
No, it'll be here. It'll just be in the loop, but not in the if. There you go. Oh my god. Let me
Did you
see.
say person found?
Okay, sure.
Okay, so let's run this. And you come with. Oh, okay. Sue was inside the
No,
list.
it's actually. Oh no. I feel like it's more easy to explain if we do this. Yeah. So first of all, if we do like I equals Tom, like it's not Sue, right? So we do person not found, and oh my gosh, it's touchscreen. And we do Selena. Selena's name is not Sue, so we'll print out person not found again. And on the third try, that equals Sue, so that's person found. That's how the loop kind of works.
Yeah, but then obviously because the computer doesn't know, like, oh, we're looking for a person, like, it's not gonna say, okay, we found Sue, and then gonna stop, right? So actually, after Sue is found, the computer's gonna keep going. It's gonna check, is Henry equal to Sue? Person not found. Is Helen equal to Sue? Person not found. So that's why it continues on for 5 times.
But if you want, you can do break. So if you type break in, it basically means that you've done what you want the loop to be. If you do break, it will just skip, like the loop will cancel and it'll move on to the next few lines. So that's what break is for. Yeah.
I've got a question.
Yeah.
So why is I like for I and so on?
It can be anything. It's what they call like kind of like a, I guess, a dummy variable. You can change it to anything. You can do it to J if you want.
Yeah, so I is just kind of like,
If you wanted to make it
general convention.
informative.
It's like saying X and Y for like algebra, right? Like when we're doing a loop, we normally use like I and J.
Yeah, this is probably a better naming convention because it says for name in the list of names. So for every name right there in the list of names. Kind of like that. So if we change that to numbers, like 1, 2, 3, 4, 5, we can make that better syntax by saying for number in the list of numbers. But instead, we can do like 5 number.
And another thing to remember is always remember your like correct indents. So you see how this first line is 4. So everything here is inside this for loop, right? So even this else is still part of the for loop. So yeah, the indents make it clear to see like what's inside.
Yeah, I actually think you get an error if you don't indent.
Oh yeah, and you
Yeah,
kind
you
of like have to.
Yeah.
Does everyone know how to indent? Tab.
Oh, you can also press tab if you like.
But you can do 5 space bars as well. If you really
We
want.
can change that. It's actually in the settings. Sometimes people like tab into like 2 spaces. So in a more complex course, you would have to change it. I'm pretty sure Sue, you do 1521. Tab is actually 8 space bars. So yeah. So it just kind of depends on each user preference. So it's just easier to press tab. Then it'll be consistent across everything. Yeah. Append. This is also something we can do to a list. So if we do dot append, it will just basically add the number that you want to the end of the list. And that's actually pretty helpful. Yeah.
Okay, it's pretty straightforward.
Do you want to do this one? It's for loop and append.
Oh wow, okay. So now we're going to combine some other things we've learned, right? So, yep, this one, if we have a list 1, 2, 3, 4, and we append the number 5, it's going to become 1, 2, 3, 5. Now, how can we use a for loop to help us with this? So here, list 2 is this. What does this mean? Yep, it's an empty list. There's nothing in the list yet, right? But we've made a list. So like, there's like a space available. So for example, like think of like you have a cupboard and you told the computer, okay, leave a space for like this list. But you haven't actually put anything inside the list. You just have an empty space, which the computer knows like, okay, I'm probably gonna have to put something in here. So now the for loop says for num in list 1. Oh, okay, we're using this list. X equals num times 2. So what is num? Looking at list 1, let's replace list 1 with what we know it is. So list 1 is 1, 2, 3, 4, 5. So imagine it says for num in list 1, 2, 3, 4, 5. Each number we're going to multiply by 2. Then that number is going to be added to list 2. Okay? So keep in note, we've got list 1, which is this, and list 2, which is empty. So okay, let's try coding that.
Okay. Do you want to do the same example or different example?
Yeah, it's just copy paste. I think it is the same example.
Oh, but it already shows you what it will create
okay.
anyways.
Oh, sure.
So
Okay,
that's kind of.
So what's happened is for num, say when num is the first one, look at number 1, x equals 1 times 2. So x equals 2. Then to this 2, we're going to add the number 2. So we've got our first one here, like this. Then the next one, we're going to do 2 times 2 and then add it, 3 times 2 and then add it, 4 times 2, 5 times 2 and then add it. So then in the end, we've got a full list with 5 numbers in it. Yeah. So you can see how like coding becomes like different things are adding on to each other that you've learned now, right?
Yeah, this is a bit too complex. Okay, yeah, plotting is actually important.
Okay, so you know how we were saying like import, like if you want to use like factorial like pi and stuff, you need to import math at the top. Now if you want to plot stuff, like you want to draw a graph, you just need to write that on the top. So yeah, copy paste that into the top of your code.
Yep. And yeah, you copy this down. Oh, we can copy something there.
Just a good question. So how come you wrote import something as something?
Okay. Do you know? Okay. So basically when you import something as like matplotlib.pyplot, it's a really long name, right? So in like, for convenience sake, you can simplify it to a name, whatever name you want it to call. So for example, if we do like matplotlib.pyplot, that's so long, and you have to keep typing over and over again. So we can just say, we want to call this really long name as just PLT. And here, if you want to access that library, we can just do PLT again, instead of like writing this big chunk in. That's basically like how it goes. So at the start, when I imported math is already really short. Like realistically, you don't really need to simplify it, right? But with this, since this is so long, we can just like simplify this to PLT, which is plot. Yeah. I can name this anything else. I can do like graph, and if I do as graph, then every single time we want to access that library, it will be graph.figure, graph.plot instead of PLT. So just change it according to what you want to name. But the general convention is this, and you will have access to the lecture slides in your final exam. So this code you don't need to memorize, but you do need to understand what the code does and where you can find it.
Yeah. So think of this as like title, y level, x label. They're all like functions that come from a different file somewhere, right? So we have some other file that has all these functions already written for us, and then this is saying, okay, we're gonna like use those, so like have it ready, okay, computer, and then we have to say PLT, which is like from that other document, I want this function, like Y label function or X label function, and then that's why it's like PLT dot X label Y label.
Yeah, we'll show you how to kind of plot everything. For me, I just kind of straight away copy and pasted from the thing. So this is just code copied from the lecture slide. So this is nothing new. You will learn this later. But I do need to generate data for X data.
Just while Selena's doing that as well, you can write something like this, import math as, and then leave it blank. And then if you want to refer to pi, you can do that without the dot math, whatever. But that's really not recommended, because then you're starting to use functions from libraries that you don't know where they come from. So when you import, you want to either name it or leave it as the library name. It's just good coding convention.
Oh wow, okay. So
We're all learning together.
Oh, yeah.
Is that what you teach? You tell your year sixes or whatever?
Yeah. Okay, so you see how now we've got like a plot, like we've literally got a graph from here, right? So once you like have data, like Selena's putting in now, it's gonna like plot points for us, and then we can like plot a graph. Have you guys seen like those graphing calculators that like just like put in the numbers and they like graph on the calculator? Yeah.
Let me just get rid of.
Okay, wow, it's given us a line. Right?
It's a linear thing, right? Because here, this is all our X data. So X right here and like Y data. I don't really need to explain this, I guess. But this is like, you can just put whatever data you want there. You can generate it however you want, but this only works with like integers and floats. But for here, you're calling it to plot a figure. So a figure is just empty right now, but we were plotting, if we want to plot it, we want to plot the X data against the Y data. So X always goes before the Y. So X data here, Y data there. And this is the label that you see here. You can change it to whatever you like X new label or Y new label. And if we run it again, it'll create a new graph. So that's the new name that I gave it. So this is all adjustable. We do it there, and that's the title. Yeah. There's also some people like doing this. Some people like it with dots, and like not, if it's not a linear relationship, you wouldn't be like, I don't know, if you don't want to like connect the lines, you can just do in the comma X and it'll plot the actual numbers down instead of connecting the lines. Or you could do like, does O work? I'm not too sure. I'm pretty sure O is dots. Yeah, O is dots, X are crosses. Yeah. Any questions? What is that?
Why is the first line just blank? It's PLT.figure and there's nothing in that. What's the purpose of it? There's nothing in that.
So it's just basically calling it to plot the figure, but we don't have anything right now, so we're just trying to populating it. So for example, if you create an empty list, you leave like the list empty, right, with the square brackets. So you're doing things after you've allocated space for it. But if you don't put like plot figure there, it wouldn't really do anything. Like that didn't do anything. That's the old graph. So yeah, put that down like that, and it'll work.
I have a question. So, you know how you wrote like X underscore data, Y underscore data, and then before you had that third input, the O, the code still ran. So how come you can sometimes give it two things, sometimes give it three things?
So if you don't give it something, it'll just automatically give it as a line. But if you want to specifically tell it to plot it in a, like, as crosses, that's just giving it that extra piece of information. So generically, you don't really need that, but sometimes they do ask for it in the labs. So just making sure you guys know. Yeah, that's pretty much it. Wow, what week are we on already? That's crazy. Wait, is it, are we on 5?
Cover NumPy, that'd be fucking...
Bro, NumPy, Oh. Okay, this is week 5 right now, and this is more lists. But this is like lists and loops. So it's like combining 2 concepts together. So like, do you feel like you guys have loops and lists like down packed right now? Like, do you understand what's going on? Because if you don't, I wouldn't recommend you go over this. Otherwise, it'll be really confusing because you're doing 2 concepts into one. So how's everyone's understanding so far? All good? Okay, yay! Oh no! Like, are there any specific like parts of the content that like or weeks that you didn't understand? We can go over it again.
I was just like, if I was after this, I wouldn't be able to. Like, I'm understanding.
Oh,
It
okay.
comes with a lot of practice. It's very different understanding.
With the if, like, okay, if this, and then what if I use if again instead of
Oh, good question.
Yeah, we can try again. If does, I'm pretty sure it does work.
Right, but basically, remember how normally you do if and then elif. So what elif means is else, like if the first one doesn't work, then else we do that one. So if we don't have elif, it's a bit confusing because like most of the time it will give like the same result, but it's slightly different because elif means it's only gonna run if it's like if the first one didn't win, right? But if it's another if, it will always run that one. So if it says okay, if this happened, okay, then it's gonna read the next line. But for example, this one's elif, it's only gonna happen if this one was not true.
the first statement needs to be true for it to
No, so wait, for this no, this one will always run regardless of if this is correct or not, because this is just the next line. But elif is only the next line if the first if was not true, then it's going to try the next one, try the next one. But this one is just the next line of code, so we'll just continue.
I'll copy that again.
Yes, so that's the slide.
Let me come up with a scenario that would actually like be different if we use elif. Coming up with an example is low-key hard. Hang on. Let me think.
Okay, so let's think about what this might like result in. So line 10 says if number is less than 20. So is the number less than 20? Oh, the number is 20, right? Number is 20. So if number is less than 20, this is not true, right? We're going to go to the next line. If number is greater than 20, no, it's not greater than 20, right? So it goes to the next line. If the number is equal to 20, that's true. So it's going to print. Okay. But for example, here, it says, is the number less than 20?
Numbers greater than 5, numbers greater than 10.
Oh yeah. Numbers
No.
greater than.
So then it will go to elif. Is the number greater than 20? No. So since it's not either of those, it will have to do else, which is equal, right? Okay, I think the example was wrong.
No. It is right. Hang on. Let me separate the cells.
Oh, so the first part?
Yeah, so we run the current cell right now. So like right now, if we're using ifs and ifs, if the number is greater than 5, which it is, it'll print out less than. But then, oh my god, I keep touching the screen. I forgot it's touch screen. And then it'll go to the next if because it's going in order. Yeah, you can explain too.
So if this was like if elif, we'll check the first one. Yes, the number is less than greater than 5, so it will print this. And then since this was true, it will just skip all the F's, right? But for this one, it says if again, so it's going to check is this true? Yes, print this. But then we're going to go to this one. Is the number equal to 20? It's also going to print this.
Okay.
So that's why we've got less than and equal. So we don't want this, right?
So that's the first loop with all the ifs. So let's try run it with the if, elif, and else. So if we run that again, it just prints less than.
Yeah, so
It should be more than,
like,
but
if the
anyways.
conditions are like related to each other.
I'm sorry. This mathematically doesn't make sense. There you go. run this, and it'll just be more than that. It'll be less than and then equal. So, any other questions?
Sorry, if you go back to the code. So for the first like structure for the ifs, it might be like, did this person pass decimal challenge? Did this person pass maths 1A? Did this person pass physics 1A? Because those are like separate courses, right? So you do 3 separate checks for it. But for the second one, say they're all like related courses, or like, for example, you can either do ENGG1811 or like Comp 1511. So if this person either passed 1811 or the Comp 1511, those are like equivalent courses, then maybe you'd want the second structure.
Okay, yeah. This is 4 loops with lists. Do you want to go over that, or?
I think we definitely have those lists.
This is a bit different because you're giving it when to stop now, which is like the length of the list. This is a bit different.
You mean like the second one?
Yeah, because like right now they're gonna do like loops with the list,
Okay, so
it's a bit harder.
yep, for the second one. So it's similar to the four loops we've been doing. Except now instead of like getting a list and then like putting it in and saying print one of each one, we're gonna just like skip a step for this and like go straight to just making a list like in the for loop here, right here, and then just print it out, right? So let's wait, go. Yeah, let's see what this is gonna give us. So do you guys remember from range? It's going from 0 up to the length of a list and going up by 1 at a time. So what's the length of a list? Yeah. Yeah, this is the second index, but there's 3 items total, right? So the length is 3. So we're going from 0 up to 3 and going up by 1 at a time. So it's going to print 0, 1, 2.
Just as a little tip, if you don't want to like actually remember what the length of it is, if you get confused, there's actually a length function, and you can just use that and like length. And if you run that, it will say like the length is 3. So if you get confused, just remember you can just like, obviously you have a really long list as well. You wouldn't be wanting to count like how long it is. So there is a function. It's just called len. Put it in round brackets and put out the list, and it'll return like how long the list is, if that helps. That's why you have length right there. That's the function. It's doing the same thing. So it's just finding the length of a list, which is here, 1, 2, 3, and it's going up by 1. But remember, it doesn't include 3 when you're doing range, right? So just stop at 0, 1, 2.
Yep.
Okay.
Okay, now this one is, so as you can see, the print, what is printed here is like 0i, 1 love, 2 coding. So it's combined like the first for loop and the second for loop, right? So how they did that is for the range in, so like this part is going to give us like 0, 1, 2, and then we're printing I, which is I from a list, so it's like I love coding, and we're also combining any list I. Wait, no. So this I is from here, so it's going from 0, 1, 2, and then we're looking at the I index of a list. So this one is going I love coding. So we printed them together like that. Yeah, so that's like something else you can do.
Does that make sense? Because it is like a bit of a harder topic. Do you have any questions about that? Or do you want to go through an example? Or?
I think they'll find it like, I think they'll like go through the struggles when they like code themselves. But like I think like the understanding is like the
Okay.
understanding is okay,
Okay. Yeah. So another way we can manipulate lists is called list splicing. And we already went through this, like the location is called the index, right? And it starts from zeros. So we kind of went over this already. But list splicing, we already told like if it's like data list 3, it will like get that number, like 0, 1, 2, 3. If for example, we want to get the 7th index, but there is no 7th index because it's 0, 1, 2, 3, 4, 5, 6, it'll come with an error. And if you do it with the column like this, it'll just print out everything. But if you do data list with the semicolon and a 3, it'll print out like the first 3 number of the list, like 0, 1, 2, 1, 2, 3, like that. And then data list with a negative number, it means going backwards. So 1, 2, 3. It does get really confusing because for some reason this starts counting from 1, not 0. So kind of just experiment in the console, cause yeah.
Okay, I have a question.
Okay.
What's the difference between
You can't do list. You have to change your name.
a list equals 3 and a... Okay,
What can you guys tell me what's the difference between these two? The second one was the first one?
The second one.
Yep, this one.
That one is part of the list, and the third
Okay.
is that.
Yep.
And then the first one is I feel like it's just like 3.
Yeah, that's exactly right. So be careful between these two. So this one, the second one means you're looking at the 3rd index, right? So 0, 1, 2, 3. So in a list, you're looking at 0, 1, 2, 3, 1 in the list. This one means the list is just, it just has 3 in it. Yeah. Be careful of that.
Yeah, and this is just basically saying you want to go from the last 3, so 1, 2, 3, which is 400, to -1, which is like right here. It stops there. So 400, 0. It's kind of a hard concept to kind of teach. It's something that you just have to experiment with manipulating the list.
okay, how much left for this one? Maybe we should do the maths challenge.
The maths challenge?
Yeah. Because we don't have that much time left anyways.
The sublist. Yeah. I think that's everything done. Like week 7 is basically numpy now, which is a complete.
You shouldn't go into numbers.
Yeah.
I feel like we shouldn't go
It's
on.
like a
Yeah, it's a completely. Yeah, this is the second half of the term, and it's a completely different concept. So, but that's all the coding that you would like kind of need. The next part of the course is a lot about like data manipulation. So if you guys have done Math 1A, you've learned about what matrices are. So this kind of deals with that, matrices, and the numbers that's stored in matrices.
Okay, let's do the maths exercise.
Okay.
Okay, like a paper or something,
Should we just end a bit earlier?
like now. Yeah. You don't want to do the maths exercise?
What is it?
It's like mental maths. I feel bad making them do mental maths. They probably already had enough.
Okay. You guys want to do it or?
Do you want to explain what it is?
Yeah, it's just like mental maths. Like literally.
Personally, I don't want to torture you guys.
You should have done it at the start.
Yeah.
Feel fresh.
Oh yeah, that's okay.
Oh, it's alright. I mean, you can just show us what it is.
Oh,
You can do it on me.
You should do
You can do it on me. I'll do the mental maths.
okay. It's a lot.
Or we could just do like lab exercises together as a group, and they can actually like use the lab exercises like later on, so they can actually use it to get marked.
But some of them haven't done the lab yet. Oh, do you still have access to like?
I have all the labs.
Oh, okay.
Like that, you guys can actually like, because your weekly labs are marked, so we can work through some lab questions if you want. Or is that plagiarism?
I'm feeling the pride.
Oh, okay, that's
Like
true.
a lot of
Yeah.
like content, but
I reckon it's just an early mark.
Yeah.
Because it's already a lot of content.
You can share the labs or whatever. Or actually, I don't know if you want to share your.
No, I can share like the lab exercises
Yeah.
because it releases week by week. But if they want to like do well in the course, they can do the exercises beforehand.
They can, but I think what I usually do in my workshops is 1 hour and then smoko and then continue. But
Oh, we did have a
they've been
smoko.
fried, yeah, they're fried. They got fried for like an hour and 40 minutes.
That's basically 20 minutes of smoko, which is perfect.
Yeah.
Yeah.
If you want to cover this.
Is that okay?
Oh, also, me and Selena run class sessions every week. We have like 3 lessons a week.
Promo.
Yeah.
Plug.
I promise it'll be way more helpful than this because like by then you actually have lab questions to go over, and if you don't understand something, we can actually help you. Whereas this is kind of like going through content, which is a bit boring. So if you actually need help with the code, because your weekly labs are marked and they go towards your final grade, and I recommend you to do like try to get as high of a pre-exam mark as possible because pre-exam mark accounts for 60% of the course. So you can literally pass the course without even doing the finals. So come in for the past sessions and try to maximize your pre-exam mark.
When are they?
Right now, Monday evenings are online, and then it's Tuesdays and Thursdays. But we will send the past session times on the group chat. Yeah.
Oh yeah, true. Okay. Yeah. Thanks again to these girls. They they volunteered their time for this and prepared a little bit. Yeah. So yeah, all good. All right. So.